Hello. So I had mentioned that I was going to make a my own kind of behavior tree system. That's a little more specialized for exactly what I needed to do. I was using Behave, and that worked fairly well. But I wanted to, like I said, make my own. Um, so that's exactly what I did, and I'm going to make this available to you via GitHub. I'll post the link to my GitHub um, as I post this video. But I wanted to show you kind of how it works and walk you through it. Uh, just kind of the basics. And yeah, so I mean, I have tested it. It works. If you all would like to test it, I would appreciate that a lot because who knows what edge cases I'm missing out on. But yeah, so we'll get to going. Okay, so what I made is it's just a basic little 3D scene. It's a platform with a navigation region. It's base. I didn't change any settings in here. I created a waypoint, some waypoint nodes. They are just node 3Ds. There's no script or code or anything on any of those. And then I have a basic character body 3D. It does have a script on it. All that does, though, is check. It stores all of your waypoints, stores a reference to the brain, which we'll get into that in a moment. And then on process, checks to see if you've hit the toggle walk button, which right now is the D key. And if it is, it toggles a blackboard value, which again, we'll get into that in a moment. And before I do get into how this whole thing works, I'm going to show you that it does indeed work. So right now, he's just standing in the middle, waiting. I hit the D key. He starts walking around. He'll hit the waypoint, and he'll navigate to the next one. And he'll just keep doing that forever, looping around all four of them. They're not in the best order. And if I hit D again, he stops. And when I start it again, he resumes, but he starts going back to the original. Just because I programmed him that way to test some more functionality. So we'll get into the character here. So before I do go through this, I'm going to look at the nodes. So let's go to AI brain. So I created, this is the base node. It doesn't do anything, so don't add an AI brain. It's just kind of so they can be categorized. In here we have actions, which an action is a list of commands for them to carry out, and they will carry them out one after the other. So they'll go through and do all the commands. The brain is the parent class, so everything needs to be a child of that. Condition contains several requirements in order to enter the state, and the state is a gameplay state. It's one state that your scene can be in. So then let's get into it. So we got my brain here. You can see it gets a blackboard that's automatically assigned. And a blackboard is basically just a dictionary with any type of value and any type of key. But those are auto-assigned. You don't have to make one. It'll make one itself. You do have to assign an actor, which has to be a character body 3D. That means that this is useless if you make 2D games. All right, I do not have a 2D version. Maybe one day. Right now it's 3D only. And then it also needs a navigation agent. Because I'm assuming that, because for me, I'm using navigation regions and navigation agents. If you're not doing that, again, this is of no use to you. You have to have those two or it will not work. Current state is assigned by the system, so you don't have to worry about that. All right, so we have our brain. If I open the script, you can see you won't need to override this. This just runs everything for you, but it's based on what its children are. And then I have two states. Roam, which is for where he's walking around between waypoints, and idle, which is, it does nothing. So we'll start looking at idle because it's the simplest. And there are two things here. This is a condition. Conditions have to be the first child of your state. If they are not, it will throw out a warning, and you won't be able to enter that state. It shouldn't error out. It might. Let's see what happens. Let's see what happens. Yeah, no errors, but it doesn't do anything. So the condition always has to be first, and it has to have actions. If I don't have any actions, it'll throw a warning. This state has a condition, but no actions, it will not do anything. Also, you only want one condition. If I had a second, it'll throw warnings there, because there's multiple conditions. You only ever want one. So, but what if you want multiple things that need to be true in order to enter the state? Well, you can add as many as you want. And these are just resources. So if we go down here, we have in the AI brain, we have script for requirement. And if we look at the condition itself, it contains a list of requirements. So what you want to do to create a new condition that must be true is I'll go into requirements, I'll create a new script, save it as type requirement, and then I'll name it something. Can do. So we'll enter this. Now it has a function named evaluate, which takes an actor, an agent, and a blackboard. Pretty much every function you're going to override takes these three. All right, and then we can say if blackboard.get data do, which has a default value of false, equals true, and we return success. Now, requirements will either return success or failure, and they must return something. So if that's not true, return failure. And that's it. And then you do need to give it a class name as well. Name can do. Right. So now if we look at my always true, I have an empty requirement here. If I look, drop down, new can do. That's it. Now that requirement has to, both of these have to return true in order to enter the do nothing state. This one, the auto success just returns success because this is my default state. It does nothing. So if all the other states above it fail, it'll go into that. So I'm going to delete can do. I'm going to get this off of my always true because I don't need that. Actions are pretty similar. So like if we go up here to roam, we have can walk. And you can see here, oh wait, no, I forgot. It uses this. It just checks to see if the blackboard has the value can walk, and it's true. And if it does, it returns success. So if that returns success, since that's the very first one on the top, if that returns success, we are going to enter into this state. Since we entered into this state, it's going to run this action. So the state's just going to loop through all of its children. You can have as many actions as you want. That's fine. Just only one condition. And your action contains commands. So commands are just like requirements. They're little custom resources that have a few codes. We'll look at walk around. Now they're going to have an on tick that you're going to override, and these are all going to take a character body 3D actor, a navigation agent 3D agent, and a blackboard. And they're going to have an on tick, on action enter, and on action exit method. On action enter will be called the first time that you entered this state. On action exit will be called the first time that you exit this state until you enter it again. These will run the next time you enter and exit the state, but only, if the previous state was not this. And then tick gets called every single frame. Other than that, do whatever you want to do in here. This one checks the waypoints, it gets a position from the waypoint, sets velocity, and then moves. And then it checks if it's finished, and if it is, it increases the index. That's all this does. I have a look to velocity, right? Same stuff here, so what we're going to do is we're going to go we'll do actor dot look at, and what we're going to do is we're going to go actor dot global position plus actor dot velocity. That's it. And just to make it a little bit more, something that we can actually see, we're going to add. No, we won't do a cylinder. That's stupid. Let us CSG blocks on it. Right. We'll move this forward on Z, like that, so we can just kind of see what direction he's facing. And so we can see it a little bit better, we'll set a material override, and we will make this purple. Alright, so now we can see which direction he's facing. I'm actually, negative Z is forward. I went the wrong way. Transform. So let's go So now, what should happen? I don't know. I haven't tested it with multiple actions yet, so this might actually fail. I don't know. But he should walk first, because that's the first action here. And then after he walks, he'll face the direction that he's moving. That's what should happen. Alright, so walk. Hey, look at that. See? Easy peasy. And if I wanted to, I could save this as a custom scene and make it reusable for other characters. But what if I want to change the order? Like, what if I want Idle to be the top priority? I don't want him to roam at all. I want Idle to be top, so I just move it up. Just move it up the hierarchy, run it again. And now he will no longer respond to when I press the D key. See? He doesn't do anything anymore. He just stands still because I moved Idle to be at the very tip top. But now if I move this back down, so now Rome is back on top, and he should start, maneuvering through again. That's it. That's the whole system in a nutshell. You can add as many conditions or actions to a state as you want. You can reorder them. You can create reusable commands for your characters, and it all uses this blackboard. That's it. Very simple. What about debugging? Well, Behave had a really nice debugger. I don't. So what I did instead, if I go over to remote and I look at my character, you can see what state he's in. Right now, he's in idle, right? Let me go back to my game. If I hit D and put him into roam, you can see now he's roaming. And I hit D again, and he stops, and he goes back to idle. So I just update his name so I can see it. That's it. So yeah, if you're making 3D games and you need some sort of character AI system and Behave is just a little bit too complex for you or does some things that you don't like I had an issue. My main issue with Behave was the on enter and on exit states. I didn't like how they functioned. And it was just some logical issues that I didn't quite vibe with. So I wanted to make my own. And as far as importing it into your project, you just need this folder. Just throw this folder in the base directory. Doesn't need to go into add-ons or anything like that. Just throw it into the base res folder for your project, and you'll be good to go. I just threw this whole system together in like an hour and a half, and it just works. So yeah, I'm gonna be rewriting my character AI using this. It works really well from what I can see. I think this will fit my needs quite a bit better, and like I said, if there's changes that I end up making to it, I will update those on the GitHub repo. The repo will only contain the base project and the AI brain folder. So feel free to download that, use it, test it, fork it, whatever. Do whatever you want to do with it. I don't care. Just let me know if you find any bugs or anything like that, and yeah, we'll go from there. All right, thanks for watching, and yeah, let me know if you use it. All right, bye.